This is lesson 8.3a. In this lesson, we're going to continue to talk about quadratic equations and graphing them. Specifically, we're going to be talking about having the format f of x equals ax squared plus bx plus c. And we're going to talk about some characteristics of these. So if the graph opens up, that means that a is greater than 0. So this value right here, a is greater than 0. If it opens down, then a is less than 0. So for example, we have positive numbers, that's greater than 0, it's going to go up. If it's a negative number that's less than 0, it's going to open down. We know in this equation here that the c value is the y-intercept. We know that the x-coordinate of the vertex can be represented by this equation right here. So the x-coordinate of the vertex is this right here. Okay. And then the axis of symmetry is x equals negative b over 2 times a. So looking at those things, we're going to use those to be able to find the axis of symmetry. We're going to use it to find the x values in our vertex for different equations and different problems. So let's look at example 1. In example 1, it says find the axis of symmetry and the vertex of the graph for this equation. So f of x equals 2x squared plus 8x minus 1. So we're going to start by finding that axis of symmetry. So for part A, we have our equation that's listed at the top, right? Because we're looking for the axis of symmetry. It tells us that we have this right here. This function will give us that axis of symmetry. So we have x equals negative b over 2a. That's something that you're going to want to remember because you're going to be using it often throughout this process. So let's jot down really quick our function that we're working with. So it was f of x equals 2x squared plus 8x minus 1. So let's look at that. When I'm looking at all of this, what are these pieces? Where do they represent? Okay, so as a reminder, this negative 1 is c. A is the 2, and B is the 8. So that's where we're getting these letters for. B is coming from here, A is coming from here. So I have x equals negative, B was 8, over 2 times A, and in this case, A is 2. So we're going to simplify some of this. I'm going to just leave this negative with the 8 for now. So negative 8, 2 times 2 is 4. If I simplify that, negative 8 divided by 4 is negative 2. So we know that our axis of symmetry is x equals negative 2. Because remember that it's that vertical line, and that vertical line is going through at negative 2 on the x-axis. Okay, so part B said we have to find the vertex of the graph. So to find the vertex, we already know now that the x value from our axis of symmetry is negative 2. So I'm going to take that and I'm going to plug it into my equation for x so that I can find out what the y value is for my vertex. So we have f of x equals 2x squared plus 8x minus 1. We're plugging in negative 2 for x. So I've got f of negative 2 equals 2 times -2 squared plus 8 times -2 minus that 1. All right, so we're going to go ahead and simplify some of this. So f of -2, 2 times -2 squared is 4. So 2 times 4 now. Plus 8 times -2 is -16 minus 1. Go ahead and simplify again. 2 times 4 is 8. Instead of writing plus a -16, I'm just going to write -16 and then minus 1. So then f of -2 equals 8 minus 16 minus 1 is going to give us -9. So when I say f of -2, really, if we think about it, that's that y value in our coordinate point, right? This was our x value. This is our y value because f of x and y mean the same thing in terms of our equations. So our vertex point is the coordinate -2, -9. All of that coming simply from the equation and using this equation over here for our axis of symmetry. All right, let's look at example 2. So example 2 says graph this function, and then we're going to find the domain and the range. So the first thing that I'm going to want to do when I'm attempting to graph this is I want to find the axis of symmetry because it's going to help me to know where the center point is, because we've talked before about how if I'm graphing it, if I know the center point, then I can go one below and one above to get my extra points, right? So I always say start with the axis of symmetry. So to find our axis of symmetry, actually, let's just jot this down as a reminder to ourselves. So I'm going to use AOS for axis of symmetry just as abbreviation. So we're going to start by finding that. So we're still using that equation that we had up here in example 1. So right there. So we have x equals -b. So looking at this, what is our b value? B is -6. So I'm going to put up here -6 over 2 times a. A is 3. So 2 times 3. We're going to simplify that. So we know that on the top here, notice it's the opposite of -6. So that would be +6 over 2 times 3 is 6. 6 divided by 6 is 1. So our axis of symmetry is x equals 1. Now that I know that, I can go ahead and find my vertex and then plot it on my graph. So find vertex and plot. So let's go ahead and plug that into our function. So we had f of x equals 3x squared minus 6x plus 5. All right, so we are taking our x value of 1 and we're going to plug that in for x in our equation. So we have f of 1 equals 3 times 1 squared minus 6 times 1 plus 5. All right, so f of 1 equals 1 squared is 1. 3 times 1. 6 times 1, or negative 6 times 1 is negative 6. And then we've got our plus 5. 3 times 1 is 3, minus 6 plus 5. So 3 minus 6 plus 5 gives us that f of 1 equals 2. So our vertex point is 1, 2. So on our graph, I'm going to go ahead and plot that vertex point. So looking at this graph, I'm going to count, based on what I have, I can just count everything by ones. I'm going to just label every other one though. So there's 2, 4, 6, 8, 10, and then 2, 4, 6, 8, 10. All right, so our vertex point was 1, 2. So I'm going to go over to 1 and up 2, put my dot. Now remember, this is also our axis of symmetry. So if I think about it, this is the dotted line that is like the folding point for my graph. So I'm going to be able to fold my graph in half on top of itself on that dotted line right there. Now, in order to continue to put points on my graph, I'm going to use my y-intercept to find 2 more points on my graph. So if I look at my equation, right, this 5 is the C value. And we remember from the top of our note sheet that it says the C value is our y-intercept. So I know that my y-intercept is 5. So we're going to use the y-intercept. Because in order for us to get our true parabola, we're going to have to have at least 3 dots. So to find 2 more points, I'll just abbreviate that. All right, so our y-intercept, we have that C equals 5. So if C is equal to 5, we know that the y-intercept point is the point 0, 5. So on my graph, I'm going to have the point 0, 5 on here. So 0, 5, I guess I should have used a different color besides that yellow. Here, let's just use the pink. I'm going to go over these dots a little bit so that we can see the distinction between the two things. So we don't think that somehow the y-intercept and the axis of symmetry are the same. There we go. Change that color up a little bit. All right, so here's our y-intercept. We're going to use this idea to find another point. So remember, the axis of symmetry means I can take this and I can fold it directly onto itself. So if I look here on my graph, this y-intercept is 1 space away from my axis of symmetry. So my second point that I'm going to use for my graph is also going to be 1 space away from my axis of symmetry. So I'm going to have at the same height here at 5, 1 space away, it's going to be right here. That's that location 2, 5. So my second point is 2, 5. Now that I have 3 dots, I can connect them to make my parabola. So we've got there's our parabola. Now they're asking us, okay, find the domain and the range. Well, on here, if I'm looking at it, remember that the domain is our x values. So if I think about it, I can continue to put in x values to infinity in both directions, and it's going to give me a value for my graph that's going to continue to go up to infinity. It's going to go out to infinity. So our domain is all real numbers. Our range, remember, it's those y values. So the range, if you think about it, I can go as high as I want to, high to infinity, but I can't get any values that are less than this vertex point here. So I know that my range is the y values that are greater than or equal to positive 2. This is lesson 8.3b. In this lesson, we're going to continue talking about quadratic functions, and specifically, we're going to be talking about minimum and maximum values. So if you're looking at this diagram up here, it says that the y-coordinate of the vertex for that equation, or that standard equation, is the maximum value of the function when a is less than 0. So if a is less than 0, we have a maximum value, which is because the graph is facing downwards. So you've got that top value here. Everything for the y has to be below that for those graphs. And then if the a is greater than 0, then we have a minimum value, because in this case, all those y values are everything above that spot because those graphs are facing upwards. So if we're looking at example 1, it says tell whether the function f of x equals negative 4x squared minus 24x minus 19 has a maximum value or a minimum value, and then we have to find the actual value. So if I'm looking at this, let's go ahead and jot that down in our notebook. So we've got example 1. Our equation is f of x equals negative 4x squared minus 24x minus 19. So I'm thinking about this. Remember, this is A, B, and C. So I know that my A value is negative 4. I notice that negative 4 is less than 0, which means that my graph is facing downwards. So if my graph is facing downwards, that means that I have a maximum value. So then I have to go and find that maximum value. So if you think about it, that maximum value is the y coordinate of the vertex. So if you look at these two graphs again, this here, that maximum value on this graph, that is the vertex. So once we find the y coordinate of our vertex, then we'll know what our maximum value is. So let's start. We've got our x equals the opposite of b over 2a. So we've got for our b value negative 24. So I have x equals negative 24 over 2a. So 2 times negative 4. All right, so that means I've got negative 24 on the top still. 2 times negative 4 is negative 8. If I think about it, I have, this is kind of like in parentheses, right? So I've got negative 24 over negative 8, which is positive 3. But this right here tells me that it's the opposite of that. So negative 3 is our x value. Now that I know my x value, I'm going to go ahead and plug that back in to find my y value. So we have f of x. Actually, we'll do f of negative 3. We don't have to rewrite the whole thing yet. So negative 4 times negative 3 squared minus 24 times negative 3 minus 19. All right, so negative 3 squared is positive 9. Negative 24 times negative 3 is positive 72. Minus that 19. Negative 4 times 9 is negative 36. Plus 72 minus 19. So if we add that all together or combine it all together, we find that f of negative 3 equals 17. So that y value for this is 17, which means that our max value is 17. Now, you would do the same thing to find the minimum value, but of course, then it's going to be the lowest number, that y value will be your lowest number on your graph. All right, let's take a look at example 2. So example 2 says, the suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by y equals 0.000098x squared minus 0.37x plus 552, where x and y are measured in feet. Estimate and interpret the minimum value of the function. So notice that this parabola is facing upwards, so we have a minimum value for this graph. So just like we did before, we're going to take our equation here and we're going to find the vertex point so that we can figure out what that y value is. So B in our function was negative 0.37. 0.37 over 2 times A, which is 0.123498. So then if I simplify this, notice I've got this negative times negative up here. So I know that my answer is going to give me a positive value. So I'm going to have x equals positive 0.37 over 2 times 0.000098 is 0. There's 3 zeros coming. 1, 2, 3 zeros. 196. So now the thing is, it's a little bit tricky sometimes to put this entire crazy looking fraction into my equation every single time. So I'm going to show you a way that you can use Desmos to help you with plugging this in and getting those values that you're looking for. Because remember, we're supposed to be taking this equation or this simplified part here and plugging that in for x into our original function. So let me just show you a way that you can do it in a little bit faster way when you have crazy fractions like that. So if I go to Desmos, I already have my function typed in here. So now I'm going to show you, if you take that x value that we just found, okay, so we have f of, now I'm going to do my fraction, 0.37 over 0.000196. And then I'm going to close my parentheses. So now you're going to notice down here, it's calculating that minimum value for me. So it's like 202.7 something, 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 something. I'm going to jot that in my notebook. 202.7, and then there's more. Because we're looking for the approximate feet for this. So let's go back to our other screen. Here we go. All right. So what we're looking for is the approximate feet. Let's make sure that that's what they want. Yep, estimate and interpret the minimum value for our function. So if we're doing this in terms of feet, the minimum value for this would be approximately 203 feet above water. And that was our minimum value. So if we look at our picture here, right, this minimum value here is approximately, looking at our height, about 203 feet above the water at its lowest point. Okay, so that's what that means for us for this question. All right, now let's take a look at example 3. Example 3 says, a group of friends is launching water balloons. The function f of t equals negative 16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it is launched. The height of the second water balloon t seconds after it is launched is shown in the graph. So we have our graph for the second water balloon and this function for the first water balloon. The height of the second water balloon, I already read that. Which water balloon reaches a greater height? So if I'm looking at this right here, okay, I notice that my y value or my y axis here is being counted by 25s, right? So 25, 50, 75, 100, 125. So if I look up here, I notice that this one has a maximum value. And I'm noticing that that maximum value is a little bit above 125. So if we were estimating, we'd say it's close to 125 feet. Okay, so let's just jot that down for just a second here in our notebook. So example 3. Our max height. Oh, let's talk about how it's the second balloon. Max height is approximately 125 feet. So now let's use our equation or function to figure out that max height for the first water balloon. So let's do x equals negative, and then our b value is positive 80. So 80 over 2 times a, and in this case, a is negative 16. So to simplify that, I've got negative 80 over 2 times negative 16 is negative 32. And if I simplify that, negative 80 divided by negative 32 is positive 2.5. So I'm going to take that 2.5 and I'm going to plug it into our function. Slide that over just a little bit. So we've got f of 2.5 equals negative 16 times 2.5 squared plus 80 times 2.5 plus 5. All right, so let's simplify this. F of 2.5 equals negative 16 times 2.5 squared is negative 100. 80 times 2.5 is 200 plus 5. So negative 100 plus 200 plus 5 gives us positive 105. So this is saying that for our first water balloon, that max height reached approximately 105 feet. So what they're asking us is which water balloon reaches a greater height. So based on what we know right here, that would mean that the second water balloon reaches a greater height. There we go.